Okay, Bismillahirrahmanirrahim. This video is about the fourth subtopic from chapter 2, which is transformation of graph. So we have total of 4 techniques, 4 method to transform your graph. The first one is the vertical shift. Okay, how can you know whether your graph having vertical shift? Okay, look at this one. Let's say fx is your original function. If you have constancy plus constancy from the function, then your graph is moving upward C units, meaning that your graph having a vertical shift upward. If you have minus C, then your graph will be moving downward C units. This is the illustration where the blue color is the original graph. If you have fx plus C, then your graph will be moving upward. The red color graph is the new one. Same goes to here. If you have fx minus c, your graph will be moving downward. How many units? C units. Okay, look at this example. Let's say you have the function of y equal to fx plus c moving upward, y equal to fx minus c moving downward. Okay, the first example is about the quadratic graph, which is you have the equation of y equal to x square. So this is the original shape of the graph. So what happened to the graph if we have y equal to x square plus 2? So plus 2 means your graph will be moving upward. How many units? C units. So just draw your new graph. Let's say the point here is 0, 0. So the new graph will be moving upward. So this is y equal to x square plus 2. And then the second one, you have y equal to x square minus 2. So what happened to your graph? Your graph will be moving downward. How many units? 2 units. So this is y equal to x square minus 2. The point here will be 0, negative 2. Just now, your point is 0, 2. So you change only your y coordinate. So y only change. X remain the same because you are having vertical shift. Okay. Look at the second example here. Your graph will be y equal to square root of x. So this is the shape. So you have to know the basic graph. Always remember the shape of the basic graph. So what happen if you have square root of x plus 2? So your graph will be moving upward 2 units. So this is your new graph. Y equal to square root of x plus 2. If you have minus 2, moving downward. The shape of the graph is still the same. This is square root of x minus 2. If the original point here is 0, 0, so your new point will be at 0, negative 2. For the pink color graph, the point is 0, 2. Okay, still you are moving the y coordinate only. X remain the same. That is your first method of transformation. Second method we call as the horizontal shift. Still shifting, but this time is horizontal. So how to know whether your graph having horizontal shift? Okay, look at this function. You have minus c, but this time around is inside the function. Okay, inside the bracket means inside the function. So your equation is minus c inside. So what happened to your graph? Moving to the right side, C units. If you have plus C inside, your graph will be moving to the left, C units. This is the illustration. The original graph is the blue color. If you have minus C, so your graph will be moving to the right side. So the red color graph is the new one. If you have plus C, moving to the left side. Okay, they contradict with the first method just now. Okay, look at the same shape of the graph. What happened if you have y equal to x plus 2 inside the bracket square? Okay, so if you have plus 2 means shift to the left side. How many units? 2 units. So your new graph will be here, moving to the left side. So this is y equal to x plus 2 in the bracket square. So the point here, original point is at the origin, 0, 0. This one will be negative 2, 0. Okay. For the second one, -2, your graph will be moving to the right side. 2 units. So your new graph will be here. This is your new graph for the function of y equal to x minus 2 square. Your point here is 2, 0. So if you look at the points, you change only your x coordinate. Okay, y remain the same because this is horizontal shape. So horizontal means you change only your x-axis. Okay, second example, y equal to square root of x. What happened to the graph if you have square root of x plus 2? So your graph will be moving to your left side. Okay, this is your new graph. Y equal to square root of x plus 2. The point here is -2, 0. And then, if you have -2 inside, moving to your right side. So this is your new graph. Point here will be 2, 0. Y equal to square root of x minus 2. Okay, the third method is a reflection. So in reflection, how to know whether your graph having reflection? You have negative at your function. So if you're negative outside the function, your graph will be reflect about x-axis. If you have negative inside the function, your graph will reflect about y-axis. Okay. Example, this is your original graph. If you have minus fx, so your graph will be reflect about x. So imagine that x is your mirror. If you have minus inside the function, this is the original graph. Your graph will be reflect about y-axis. So this is your mirror right now. Okay, look at example. For the quadratic function, if you have y equal to negative x square root 2. So this is inside the function. Your negative is inside the function. So your graph will be reflect about x-axis. Reflect about y-axis. So this is your original graph. This is your y-axis. So what is the new graph? So imagine that y is your mirror. So the new graph will be equal to the original graph. Okay, because you are reflecting your graph here about y-axis. So this one, if you expand, actually negative x squared will be x squared. So that's why the graph is equal to the original function. But if your if your negative is outside the function, which is you have negative x squared, so your graph will be reflect about x-axis. So x is along x-axis is here. So original graph is facing upward. So the reflection will be facing downward. That is your graph of y equal to negative x squared. Alright, second example, y equal to square root of x. So what if your question asks you to sketch the graph of square root of negative x? So negative here is inside the function. So your graph will be reflect about y-axis. So the new graph will be here, reflect about y-axis. So this is y equal to square root of negative x. So if you look at this graph, this is all along the negative of x. So if you substitute, for example, let's say x is -1. You substitute here, negative times -1 is positive. So you have only square root of 1. So that's why your x here is all negative value. Because negative multiply with negative, you have positive at last. Okay, what happen if you have negative outside the function? So your graph will be reflect about x-axis. So where is your new graph? This is your new graph, which is reflecting about x-axis. So this is y equal to negative square root of x. Okay? Okay, that is the single transformation. Okay, let's say in one question you have various types of transformation techniques involved. So make sure you follow these steps for transformation techniques. First must be shifting horizontal. Shifting horizontal is either to the right side or to your left side. So the function will be fx either plus or minus c. So the constant c is inside the function. So this is your first method. Compulsory for the first method of shifting horizontally. Second method is reflection. So reflection is either the negative is outside the function or the negative is inside the function. Okay. Then the third one, this one will not cover yet, the stretch and compress. Okay, move to the last step, which is shifting vertically. So this one is either going upward or downward. So how the function? Fx plus or minus c. So the constant c here is outside the function. So make sure this is your last method. Okay. If you don't have any stretch compress, you can jump from reflection to the last step. But the second and the third step here, actually you can switch. This one you can switch either one first. Either you want to do stretch compress first or you want to do reflection first. But the compulsory step to follow is the first and the last one. First must be shifting horizontal. Last must be shifting vertical. Okay? Okay, look at one example combining the three transformation that we learned just now. Okay, look at this question. Let's say the question is, sketch the graph of this function using transformation techniques and show step by step. Okay, that is the question. Okay, if you look at this question, how many transformation involved? You have negative outside the modulus, you have plus 2 inside the modulus, and you have minus 2 outside the modulus. So you have three things. Okay. Recognize, first step is you have to recognize what is your basic function. So basic function will be y equal to modulus of x. Okay, first thing first is compulsory to know what is your basic function. And then, which is your first transformation step? Shifting horizontal. Is there any shifting horizontal here? Yes, you have plus 2 inside. So this one will be your first transformation step, which is shift to the left 2 units. Plus 2 means shift to the left 2 units. Okay. Then you have the reflection, which is negative. Negative outside means reflect about y or x. Negative outside means reflect x-axis. Okay, negative outside. That is your second step. And then the last step will be shifting vertical. How to recognize? Plus or minus c is outside the function. So the function here is modulus. So minus c here is outside the modulus. So that one will be your last step, which is step number 3. Shift downward 1 unit. Okay. So let's start step by step. Make sure your first graph will be your basic graph only without any transformation yet. So the basic graph will be y equal to modulus of x. So how is the shape of your basic graph? So the basic graph is always the V shape for the absolute value or modulus equation. And then usually question will ask you to show at least 2 points on the graph. So let's say we choose here origin 0, 0 and then another 1 point here. Let's say when your x is 1, what is your y? 1 also, yes, correct. Okay, so let's say that is your 2 points. So make sure for all the steps you show the movement of these 2 points. Okay, so second graph will be your first step. So what is your first step? Shift to the left side 2 units. Okay, So this is your basic graph. All the points on the graph will be shift to the left side to units. So the new graph will be here. This is your new graph. Which is what happened to the first point here. The first point 0, 0 will become negative 2, 0. And then 1, 1, if you move to the left side 2 units, the new point will be at negative 1, 1. Okay, that is your new points. And then one more compulsory thing is for you to write the explanation. Okay, so what is the explanation here? What happened to this graph? Shift to the left. Shift to the left. How many units? 2 units. Okay, make sure you have the 3 things. Each step must have 3 things. Okay, what is that things? You must have the equation. The equation here is only for that particular step. The step is shift to the left. So you have only plus 2 inside the modulus. Then you have the graph. The third one, you have the explanation. Okay. First is function, stated. Second is graph, sketch. Third is explanation, also stated. Okay. Then move to the next graph. So the next graph is what step? Second step is reflect about x-axis. So what is the equation? You have to write y equal to negative modulus x plus 2. This is extra method needed for this step. So this graph, if you reflect about x-axis, so your new graph will be facing downward. That is your new graph. Point on the x-axis remain. This one still negative 2, 0. But the second point, negative 1, 1. If you reflect about x-axis, the new point will be here, which is negative 1, negative 1. And then what is the explanation here? Reflect about x-axis. Okay? And then the last one is the last step, which is shift downward 1 unit. So from this graph, all the points will be moving downward 1 unit. So just sketch only the graph. Okay, let's say this is your new graph. What happened to the point here? From negative 2, 0 will be at negative 2, negative 1. From negative 1, negative 1 will be negative 1, negative 2. Okay, the function here is complete, equal to the original question because it involves all the steps. Okay, what is the explanation? Shift downward. Shift downward. How many units? 1 unit. Okay, that's how you sketch the graph using transformation techniques. Make sure show step by step, starting with the basic graph. So make sure recognize the basic graph first. Okay, how to check whether you have the correct graph? Your last graph is correct. So you can try to substitute any points. Okay, let's say you choose this one. Okay, let's say you choose this point. What is your x? X is negative 2. So substitute x into the original question. Okay, let's check your answer. Your equation is y equal to negative modulus. Let's say your x is negative 2. So negative 2 plus 2 minus 1. Okay, what is your answer? Negative 2 plus 2, 0. 0 times negative is 0. 0 minus 1 is negative 1. Okay, is it equal to the y coordinate from your graph? This is your answer. This is your graph, which is equal. So you have the correct coordinate here. Okay. To double confirm, you can check for the second point. Just substitute x into the equation. If you have the y value equal to the coordinate, then you have the correct graph. Okay. Checking it is not compulsory. It just for you to make sure you have the last correct graph. The last graph is correct. Okay, so that is the example of the combination for all the 3 steps. This is the last method, which is either you are having stretch or compress. Okay, so look at the constancy. Constancy right now is you multiply constant with the function. Okay, before this, for shifting, your constancy is either plus or minus operation. But this one is multiplication of constancy with the function. Okay, how to know whether your graph having stretch or compress? Okay, look at the condition of C. So you have the C condition here. If the constant more than 1, then your graph will be stretched vertically. Okay, stretched vertically. Look at this illustration. The blue color graph is the original graph. Then, if your C is more than 1, meaning that you stretch vertical, meaning that you stretch your y-axis here. So what happened to the graph? Stretch y-axis, so this is your new graph, the red color one. Stretch also the y-axis from downward, your new graph will be here. Okay, imagine that you stretch your y-axis, you tarik y-axis. So this is your new graph. Then the second one, if your C is in between 0 until 1, example 1/2, 1/5, 1/7, then your graph will be shrink vertically. Shrink is also similar to compress. Okay, usually madam use the word compress. So if your C is 0 until 1, the graph will compress vertically. So this is your original graph. Imagine that you compress vertically your graph. So the graph will be the red color one. Okay. Okay, look at this example using the quadratic shape. If you have vertical stretch or compress, if your C is more than 1, vertical stretch. If your C in between 0 until 1, vertical compress. Okay. Example, y equal to 2x squared. So the constant 2 here is outside the function. Okay, constant 2 is outside the function. So your graph will be vertically stretch. Okay, vertically stretch. So imagine that this is your original graph. Okay, what happened if you stretch your y-axis? So your graph will be here. So this is your graph of y equal to 2x squared. Okay, what happened to the point? Okay, method to know the point is multiply y coordinate with C. That is your method. Multiply y coordinate with the constant C. So let's say we choose one point here, 1 and 1. For example, when your x is 1 squared, y is also 1. So what happened to the coordinate here? If you stretch vertically the graph, multiply y coordinate with C. So where is your y coordinate? This is your y coordinate. 1 multiply with C, your constant C is 2 right now. So 1 times 2 is 2. So the new point will be at 1, 2. 1, 2. That is your new point. You change only your y coordinate. 1 become 2. X remain the same because you just stretch vertically. So you only change your y coordinate. What happened when your C in between 0 until 1? For example, your C is half. So your graph will be vertically compressed. So how the graph is vertically compressed? Imagine that you compress your x-axis. So your graph will be here. So that is your new graph of y equal to... this is the new graph of y equal to half x squared. What happened to the point? Let's say this is your point. Multiply y coordinate with C. Original y is 1. 1 times half is half. So your new point here will be 1 and half. Okay, 1 and half. That is the movement of the y coordinate if you have vertically stretch and compress. Okay, second, the last one. This is the last one. Horizontal compress and stretch, or horizontal shrink and stretch. Okay, how to know whether your graph having horizontal or vertical stretch or compress? Look at the constant C. Just now for vertical, C is outside function f. Right now, your C is inside the function. If your C more than 1, your graph will be compressed horizontally. If your C in between 0 until 1, your graph will stretch horizontally. Okay, so this time around you will change only your y coordinate because you are having horizontal compress or stretch. So imagine that this is your original graph. If your C more than 1, compress horizontal. Bayangkan you mampatkan your x-axis. So this is your new graph. Then if your C is in between 0 until 1, you stretch your x-axis. So the red color is the new graph. Okay, look at example. C in between is horizontal stretch. C more than 1 is horizontal compress. Example, let's say you are having y equal to 2x inside the bracket square. So the constant 2 here is inside the bracket. So your graph will be C is more than 1. So horizontally compressed. Horizontally compressed. So this is your original graph. So what happens if you compress horizontally? So the new graph will be here. If you compress horizontally, y equal to 2x power of 2. Okay, let's say the original point is at 1, 1. For example, this is 1, 1. So the new point is, okay, look at the method here. Okay, look at the method. The method says that you have to multiply x coordinate with 1 over c. Okay, with 1 over c. So what is your x coordinate? X coordinate is 1. So 1 multiply with 1 over c. Your c is 2. So 1 multiply with 1 over 2 is 1 over 2. So the point here will be 1 over 2, 1. Okay, you change only your x coordinate. Y remain the same. Okay, second, if you have this one, if you have half x squared, half x inside the bracket squared. So your constant c here is half, and then inside the bracket means your c will be in between, so your graph will be horizontally stretched. So imagine that you stretch your x-axis here. So what happened to your graph? Your graph will be here. This is y equal to half x square. So what happened to the points? Okay, this is your points, which is multiply x coordinate. So what is your x coordinate? 1. This is your x coordinate 1. So you have 1 multiply with 1 over c. 1 over your c is half. So 1 multiply with 1 over half is 2. So the point is 2, 1. Okay. This is 1, this is 2. This is 1. Okay, look at this one. The coordinate change is only for the x coordinate. Half, 1 and 2. Y remain the same. Why y remain the same? Because this one involving horizontal stretch or compress. Horizontal means you change only your x coordinate. Y remain the same. If you can find the relation, actually, this is the graph of horizontal compress, which is equal to this graph. This graph is what? Vertical stretch. So actually, vertical stretch is equal to horizontal compress. Imagine that you stretch your y, so automatic your x indirectly become compressed. That's why you have the relation between that two. Okay, so hopefully clear with all the explanation for the stretch and compress. Okay, let's look at the basic example first. Y equal to fx, the basic function. Let's say we have the function of square root. Okay, so the basic function here is actually y equal to square root of x. So if you have 2 outside the function, this one will be vertically stretched. Okay, this is vertically stretched. 2 is outside, vertically stretched. If half is outside, vertically compressed. Okay, this one is related to your C more than 1. This is your C in between 0 until 1. So vertical stretch means this is your original graph. If you have vertical stretch, imagine that you stretch your Y. So your graph will be here. Okay, that is your new graph. If you have vertical compress, imagine that you compress Y. So your new graph will be here. This is Y equal to half square root of X. Just now is Y equal to 2 square root of X. Okay, what happened to the point? Example, we take this one as our original point. When X is 4, your Y is square root of 4 is 2. Okay, let's say that is your original point. Okay, what happened to this point for graph vertically stretched? Okay, how is the method? Method is you multiply your Y coordinate with constant C. Okay, so this is your constant C. 2 times 2 is 4. So your new point here will be 4 and 4. And then the second one, multiply Y coordinate with the constant C. Your C here is half. 2 times half is 1. So your new point here will be 2 times half is 1. So the point here will be 4, 1. Okay, that is your new point if you have vertical compress. If let's say the constant is inside, so what happens if the constant inside? Your graph will be horizontally compressed. Why compressed? Because your C is more than 1. So if your C more than 1, horizontal compress. If your C is in between 0 until 1, your graph will be horizontally stretched. Okay, look at this one. This is the basic graph. From the original point for 2. If the graph is horizontally compressed, so imagine that you compress your X. So your new graph will be here. This is your new graph. Y equal to square root of 2x. Okay, what happened to the points? Remember the method is multiply X coordinate with 1 over C. So your X coordinate here is what? Your X coordinate is 4. 4 times 1 over your C is 2. So the new point here will be 2 and 2. Okay. For the second one, this one is horizontally stretched. So imagine that you stretch your x-axis. So where is your new graph? This one will be your new graph for horizontally stretched. With the function is y equal to square root of half x. And then what happened to the point? Your original x is 4. So 4 times 1 over your C right now is half. So 1 over half is 2. 2 times 4 is 8. So your new point here will be 8, 2. Okay. So you change only your x coordinate if you are involving with the horizontal stretch or compress. Okay, let's look at one example that combine all the transformation. Okay, look at this question. Sketch the graph by using transformation techniques, starting with the basic graph and show at least 2 points. So this is the given function. Okay, if you look at the function here, how many transformation involved? You have negative outside the square root. Okay, first thing first is you have to recognize the basic graph. Okay, what is your basic graph here? Y equal to square root of x. So anything that add on with this function, that one considered as your transformation techniques. So you have negative outside. You have also constant 2 outside the roots. You have negative 1 inside the roots. And then plus 3 also outside the roots. Okay, look at the step. Recall back the step just now. First step must be shifting horizontal. So how to know whether your graph having shifting horizontal? If you have plus or minus c inside the function. So that one considered your first step, which is shift to right or left. Negative 1 minus 1 means shift to the right side 1 unit. That is your first step. Okay. And then you have negative outside and also constant 2 outside. So this one you can choose either one first. Second step and the third step you can have reflection first, or you can have vertically or horizontally stretch or compress first. Either one. Okay. So let's say we choose this one as our second step, which is negative outside reflect about x or y. Outside is reflect about x-axis. Okay, that is your second step. And then you have constant 2. This one also outside the function. So if outside is vertical stretch or compress. If the constant 2 multiply with x inside, that one is horizontal stretch or compress. So this one you have to remember, recall back the condition for C just now. So this one C is more than 1. So this is vertically stretched. That one you have to remember. Vertically stretched by a factor of 2. By 2 units. Or we write by a factor of 2. By a factor of 2. So easier for you to find the coordinate, which is multiply with the constant 2. And then the last step is plus 3 outside here. Make sure last step must be vertical shift. So this one your graph will be shift upward 3 units. So total of 4 steps involved. So make sure don't make mistake for each of the steps. First graph must be basic graph. So what is the basic graph of y equal to square root of x? So make sure you sketch the basic graph first. So this is your basic graph. Okay. And then show at least 2 points on the graph. Let's say we choose at the origin 0, 0. And another one here. When your x is 1, what is your y? Square root 1 is also 1. You can choose also, let's say, when your x is 4, square root 4 is 2. Another point that you can choose is 4, 2, 9, 3, 16, 4. But the most easiest one is these 2 points. Okay, then show all the movement of these 2 points for each step. Okay, second graph will be your first step, which is shift to the right side 1 unit. So what is the function involved? Square root of x minus 1. So just write this one only for the second graph. Okay, x minus 1. So the graph will be shift to the right side 2 units. So this is your new graph. This is your new graph, which is the new point will be at 1, 0. And then this one will be from 1, 1 become 2, 1. And then don't forget to write the explanation also, which is what happened to your graph. Shift to the right. Shift to the right. How many unit? 1 unit only. Okay. Then the next graph will be your second step, which is reflect x-axis. So reflect x, only add on the negative symbol in front of square root of x minus 1. So the previous graph is this one. If you reflect about x-axis, so the new graph will be here. Point on the x-axis remain 1, 0. 2, 1 become 2, negative 1. So x coordinate will reflect. And then your explanation here is what? Reflect about x-axis. Okay. Then the next one is 2. Constant 2 outside, vertical stretch by a factor of 2. So if you say vertical stretch, you change only the y coordinate. So y only change for vertical stretch or compress. X remain. So the graph vertical stretch. Imagine that you stretch your y axis. So you just sketch only the graph. Okay, let's say this is your graph. Okay, point here will be 1, 0. So 0 is your y-axis. Remember the method, multiply y-axis with constant c. So your c here is 2. So 0 times 2 is 0. So this one remain 1, 0. For this coordinate, 2, negative 1. Negative 1 multiply with 2, you have negative 2. So the new point here will be 2, negative 2. 2, negative 2. So examiner will look at your coordinate. How you change the coordinate? Is it tally with the explanation? Okay, what is the explanation here? Vertically stretch by a factor of 2. It means that you multiply y coordinate with the constant 2. Okay, the last graph, which is you have plus 3. Outside means your graph will be moving upward 3 units. Okay, so all these 2 points will be moving upward 2 units. So just sketch only the graph. Okay, let's say this is your new graph. From 1, 0, the new point will be moving upward 3 units. So the new point will be at 1, 3. This is 1, 3. 1, 2, 3. And then the second point, 2, negative 2 is if the point moving upward 3 units. So the new point will be at 2, 1. That is your new point, which is 2, 1. Let's see, this is 1, this is 2. Okay, that is the movement of that 2 points. Explanation, don't forget to write the explanation here, which is shift upward. How many units? 3 units. Okay, so that is your last graph. Okay, how to check whether you have the correct graph? Try to substitute points. Let's say this is your x, which is 1. Try to substitute. Y equal to, into the question, negative 2 square root of 1 minus 1 plus 3. Okay, what is your answer for y? 1 minus 1 is 0. 0 times negative 2 is 0. 0 plus 3 is 3. Okay, is it tally with the answer just now, with the coordinate? Your y is 3, your coordinate is also 3. So you have the correct last graph actually. Okay, then some question ask you to find domain and range. How can you find domain and range from this last graph? Domain is what? Domain is x-axis. So where is along the x-axis that you have the graph? This one you don't have any graph. At x equal to negative and from 0 until 1 you don't have any graph. But you have the graph here. This one you have an arrow, right? The end graph should have an arrow. So your graph, your domain is starting from 1 onwards, which is from 1 until infinity. That is your domain. 1 is included, so square bracket here. What happened to the range? Range is your y value. So where is along the y-axis that you have graph? So the graph here is continuous until negative infinity. And then we stop until 3. You don't have any graph above 3. So your range will be negative infinity up until 3 only. This one also square bracket. Why? Because you have the graph at point 3. Okay, so that's all for the transformation subtopic. So you can do the homework after this. Thank you.